All right, guys, thanks for coming. This is the last of our tutorials for Brown Dog. This is going to be about Polyglot. This is a program, a piece of software we developed starting about 5 years ago with the National Archives. It has to do with file format conversions. It started off to solve a problem to deal with identifying an optimal file format for preserving data long term. And from that, it's kind of evolved over the years to do a lot of different things, and it's broken up into separate applications as well. Versus came out of that. The Conversion Software Registry came out of that. And so I'm going to kind of touch on all of that stuff and try to give a decent history of how it's evolved over time from the beginning, how it started, why we built it, and go from there. So I'll include in there examples of how to use Polyglot. I have some videos in here showing how it's used on the web interface, the REST interface. I have some examples of a code of how to call the APIs in Polyglot and the thing underneath it, which drives it, the software servers as well. And at the very end, we'll have a little bit of hands-on where you can try some of this stuff out if you set up your VMs with Windows 7 and Polyglot installed on them. So Polyglot, the name, in case you're curious, it's a word that means somebody who speaks many languages. And so I thought it was a cute way of describing something that did file format conversion, speaks many format specifications. So anywho, that's where that comes from. And so over the years, a number of us have worked on this, from Rob, Michael, Chris, Liana, and now Ashwini, and Peter, who was the one who started it with me 5 years ago. So getting started then. So the problem that we were addressing with the National Archives is that so they're charged with preserving data, and they're still, even today, trying to get a handle on digital data. They're used to paper data, physical artifacts. And so digital data brings with it a whole set of new problems that they have to deal with. And so one of those things is file formats. So their mission is to preserve all data from government agencies or businesses that work with government agencies for, I think it was 1,500 years after the fall of the Republic. So that's a really long time. And in the digital world, where software has lifespans of 10 years and file formats and data have lifespans as well, that's not really realistic. So they were really concerned about how to save this data when they're getting all these different file formats from government agencies and they can't read it themselves now. So they were curious what to do about that. And they were really interested when they started with us in 3D data. So in particular, CAD models. So the government contractors build ships, build planes, build whatever. They make CAD models of the parts that go into these things that they build. And NARA has to save these things. So they come in various file formats. They try to restrict what formats they use, but that never works out. They basically use whatever software they have in-house, what they're used to. And I think there's some sort of regulations, but there seems to be some sort of waiver process where you can get around them. So they have a bunch of different files they have to deal with. So that's basically the problem. There's abundance of file formats. It's a problem for preservation. Why? Well, first of all, do you even have the software now? But if you do have the software now, will the software still be available to load that file format in the future? So think about way in the future, a millennium. And not even that, really, just a decade or two. And so there's that. If the software isn't around, do you have the specification, the document that describes the file format, what each byte in the file represents? What data does it actually represent? And was the specification even available in the first place? So a lot of formats are proprietary or closed. So basically some company makes up their own file format for their product, and they don't release the specification. So you save your file in that format, and that's it. You rely on that software to open that file. And sometimes people have tried reversing engineering some of these things, but that's a lot of work. And then the format also, since it's proprietary, can change over time as a company adds new features to their software. So it's a constant race to keep up with that. So that's a big problem. So again, we started with 3D data. So we started out by looking at 3D data. Really is a good example of the problem with file formats, because it seems like every company that makes 3D software also makes up their own 3D file format. So I put together this little slide several years ago to kind of capture that feeling. So basically, here's AutoCAD, and it has its, of course, its popular DWG format. There's another program which is 3D Studio Max, which has its own formats as well. Then there is Blender. Blender has its own formats. There's, what is this, K3D, Unix 3D program, has its own formats. Wings 3D has its own format. Maya, another popular 3D package, its own formats. Autodesk Inventor, it has its own formats. What do we have here? It's what do you call this one? Lightview, I think is the name of the program, has its own format. Cinema 4D, and so on and so on. Adobe started making its an application to deal with 3D formats too, but it's spit it out as PDFs. And can I get rid of this thing at the top? I don't know how to get rid of this thing. Anywho, it saves it as PDFs, which internally stored as the 3D data as U3D or PRC formats, and so on. So Google SketchUp, VTK, ParaView, they have their own formats as well. Google SketchUp has its own format as well. So on and so on and so on. So we tried to count as many 3D file formats as we possibly could by going through all the 3D applications we had available to us and just looking through the open and save operations that they supported. And we got to around 140-something file formats, and we basically documented them here, and then we kind of gave up because it just never seemed to end. So there's a lot more, I'm sure. So basically, that kind of represents the problem pretty well in terms of at least 3D data. So what do you do about that? So you have all these different files that you're getting from various agencies. They come in different file formats. You want to preserve them. One thing that you could do in terms of preservation is to try to convert those files into some other format that has some chance of surviving through time. Some open specification format, something perhaps from the open source world that's well documented, popular, standardized. So that would be one possibility to do that. And of course, you'd save the original for provenance, which is something you should always do. So the idea is with one format, you would then throw all your resources towards supporting that one format once you convert all your data to that, and that's all you would care about. And ideally, that's all you had to worry about in terms of preservation. But the question then becomes, well, which format do you choose for that kind of thing? So there's several ways you can do this, and we decided we didn't want to just kind of do a hand-wavy thing. We wanted to do a more scientific, empirical process of deciding what that best file format was. So that's kind of where I'm going to go with this in terms of Polyglot and what it was all about, trying to empirically state this file format is the best file format for some particular needs. So, so how do you do that? So first of all, you need a converter to be able to convert to whatever format that is, and that is a problem in itself. So fully supporting the many available file formats out there is an enormous undertaking. There's, I would say, thousands of them. Many of them closed specifications, many of them with large specifications. The step file formats, 3D file format, thousands of pages in the specifications. So it's a huge undertaking, and if it's even possible, I would go borderline impossible. So so that's a problem. And there's another issue with that as well, is that in terms of, that's inevitable with terms of file format conversions, even if you do have a converter, is that there's an aspect of information loss in that no two file formats seem to have the exact same information stored within them. So a 3D file type is a 3D file type, but sometimes they store different things in them as well, such as different ways of representing the vertices or the faces, or different ways of representing the 3D model in itself. Sometimes they have stuff like animations or physics properties or lighting properties and so forth. And if one format supports that, another format doesn't support that, you lose that information. So I'm talking about not just CAD models here, but actual 3D graphics models as well, and just kind of bundling them all together. So you have to take that into account. And so that is just a fact of life in terms of converting files, is you have to expect that you're going to lose some piece of information sometimes. And so it's kind of important to keep track of that. So going back to 3D data, one of the big things is there's different ways of storing 3D content in itself. One common way in graphics is a faceted model, where basically it's vertices and faces, so it's a mesh. That's a pretty simple way of representing a surface. In the CAD world, there's something called BREP, boundary representation, where it's a bunch of curves and the way they intersect with each other on surfaces that kind of capture a smooth surface better than you could with a mesh. A mesh is discrete, sampled surface. There's triangles. BREP is smooth. It's continuous. You can zoom way in on it, and it still looks smooth. And there's another method called constructive solid geometry, where you basically take a bunch of primitive shapes like cylinders and spheres and squares, and you add them together, subtract them together. And it's another way of getting smooth surfaces as opposed to sampled surfaces. So there's a number of ways of representing 3D data. Now, in terms of going from one of these representations to another representation, some of them are doable, some of them are not. So like you can go from BREP to a mesh. You would do that by sampling the surface. You basically go over the curve and sample points, vertices every once in a while, and get that out of there. There's a consequence to that, because you're taking that rather simple to represent in memory curve and turning it into potentially thousands of vertices now, so it expands, it grows in size. Plus, it's now aliased, it's discrete, so if you zoom in on it, you see those vertices where before you didn't see those vertices. So there's a consequence to it. There is an aspect of information loss right there. The opposite, going from a faceted representation back to VREP, is not trivial at all. So that's kind of getting into the AI kind of things, is how do you determine these set of triangles are part of some sort of curve? How do you tell it's a sphere? So you can kind of try to fit it to a sphere, but there's going to be noise, there's going to be variable information loss if you can do it at all. So that's something you have to keep in mind as well. So we kind of try to compare some of the features that are stored in a couple of different 3D file formats, such as 3ds, IGES, Lightwave, OBJ, and others, and stuff they store in terms of geometry, such as faceted models, parametric curves, CSG, BREP, appearance stuff like color, material, texture, bump maps, scene stuff like lights, views, groups, and animations. And we try to find what each supported, just so we can kind of see what overlaps there were and what not overlaps there were. So as you can see there, not everything is checked in every one of these. So if you try to go from one format that has one thing to another format that doesn't, you're going to have to do something about it. You have to change the representation or drop the information loss. So again, this kind of thing happens, I would say, with all data. And this is just kind of easy to see with 3D data, which is also what we were looking at first. So that brings us to the question as how do you track information loss? And again, we were trying to do an empirical study here on picking a best file format. So how do you empirically track information loss? And then get back to our main question is, which is the best format in terms of preserving data? So this kind of gets into where Polyglot came from. So the idea here is conversion, information loss, because that's just a fact of life with this conversions, and using optimal file formats. So let's assume we have a universal converter that can convert from any file format to any other file format, any format A to other format B. To measure information loss, what we could do is look at the file, load the file. If we had a way of loading the file independent of the file format, which is kind of a catch-22 situation, but we deal with that at the end. Before we converted it and after we converted it, look at, let's say, the 3D model before and after, and if we had some way of comparing that data based on that content, not the file format, we could kind of assign some sort of weight as to how much changed, what's different in the 3D model before and after that. And based on that, we can derive an empirical means of determining an optimal file format. So within the context of our goals here in digital preservation, we can define that format as one that retains on average the most information when converted to by other formats. The idea here is we're being given a bunch of other formats, whether we want to or not. We want to convert to this ideal format, which we have yet to determine. So we run a study where we take a bunch of sample data, convert it to every format to every other possible format, and see which of the goal formats results in the least on average amount of information loss. And we'll just say that's our best optimal format. Clearly, it's dependent, if you do that kind of thing, on the data set that you use and on the conversion stuff that you use to make that conversion engine work, which is part of what Polyglot is. Did you have a question, Anna? Oh, okay. So basically, that's what Polyglot is all about. So in terms of actually, to make this whole process work, the first step is a universal converter. So that doesn't exist. So what that really means is a conversion. It's not just software that does conversions, but actually software that has any software that deals with 3D data that can open a file and save a file. That's, if you can open it in one format and save it in a different format, it's doing a conversion for you. So there is no, in the 3D world, there really is nothing like ImageMagick in the image world, where you can, ImageMagick supports a heck of a lot of formats in terms of conversions. There's nothing quite like that in the 3D world, and there's many formats in the 3D world with closed specifications, so that makes it a lot more difficult as well. So there are attempts to deal with file formats in addition to what Polyglot does. Polyglot's a bit different. It tries to be more practical about it, but there are other attempts that, if they could work, would be great. So, such as defining machine-readable specifications for file formats. So the idea is that if you have a file format, and ideally a proprietary company, would do this too for the proprietary formats, they would write their specification not in a document, but in this schema that's readable by a machine. So there's languages like DFDL and Express and other languages where you can potentially do that in. The problem there is that specification has to be written by somebody. And in terms of old formats, that's probably not going to happen. In terms of proprietary formats, that's probably not going to happen. Even if it was doable, it's a lot of stuff. It's probably not going to happen. So Polyglot tries a very different route in terms of dealing with file format conversions. And the idea here is that it uses this idea of software reuse. So the idea is I can't re-implement the specifications for all these file formats. It's just not practical. And plus, they're going to keep changing. Some of them are closed. I can't even get access to them. It's just hopeless. So the idea is there's all this software out there that opens and saves different file formats. And the idea here is use the software that does it. Whatever is out there, anything, and just bring it all together in a consistent manner and control it, use it as needed in order to carry out file format conversions. So the idea here is something we call software reuse. It's kind of analogous to code reuse. And the idea is you have code, reuse it as much as possible in terms of, you gain benefits in terms of it's less buggy, it's robust, it makes better code. And the idea here is it's software that we're talking about here. So the idea is it doesn't have an API to it. You can't program against software, usually. And so the idea is to attach an API to software. So that's kind of what Polyglot is about, is basically attaching a programmable interface back on top of compiled code so that I can, again, program against it and call its open and save operations to chain together a bunch of software to make a massive conversion engine that's universal, in quotes. So an idea universal in the sense that it's potentially extensible. You can just keep adding stuff to it. So the way Polyglot worked, and this is the original version back in 2009, version 1, is it basically scripted applications. So there's a number of different interfaces to applications. There's easy stuff like command line applications, and then there's not so easy stuff like GUIs. So GUIs are meant for human beings to use, not really for machines to program against. So we basically looked at those as kind of the hard stuff that we had to deal with. And so to deal with that, we used a language, which I'll get into more detail later, called AutoHotkey. So AutoHotkey is a language that's all about scripting GUIs. It's one of several that do that, and we chose that one initially, although we can support any of them. And so the idea is we would script the GUI application in terms of getting access to its open and save operations so that we can then call them to carry out file format conversions. So we would then do this for a number of applications, and then we would create simple workflows that would connect open and save operations between different applications and chain them all together so that we can do more conversions than any single application can do. So potentially using 3 or 4 applications to get to a specific target file format, where possibly you have to go through a number of intermediary file formats. This, of course, it possibly includes more information loss, which you have to track, but that's a consequence of being able to do this. So part of this as well, the initial version of Polyglot included some aspect of comparing the files before the conversion and after the conversion to measure that information loss. And it would then assign that to this little workflow here to kind of pick later on paths in this workflow that resulted in less information loss. And this was, what we used back then was, and it's still available now, it's this package called 3D Utilities, since we were focusing on 3D data, and it had incorporated into it a number of ways of comparing 3D models. So, and this was a distributed system across multiple machines, so allowed for horizontal scalability. But so basically, that was kind of the first take on Polyglot, and it was pretty much one big mess of code. But there were several aspects of this that were interesting, and they kind of came out as separate frameworks that we are developing now separately. So this eventually evolved into what I've been calling as the ISDA tools for digital preservation. So a number of things were pulled out of this. The original Polyglot, but became Polyglot version 2, which is what we use now. And one of these things was something we decided to isolate because to me at least, it seemed important on its own, and that's something called a software server. And this is the thing which by itself attaches the API to software. So the idea is it's a kind of an independent thing in terms of file format conversions. It deserves to stand on its own. So that was one aspect of it. And then what also came out of this was the Conversion Software Registry. This is a database of software in terms of indexed according to what they can open and save. It's kind of a way to find what software you need for your particular needs. Polyglot 2, which kind of glued all these things together. And Versus, which Luigi already talked about, came out of this too, is in terms of the 3D utilities got put into that. And what Versus is being used in terms of identifying information loss in Polyglot 2 now. So first I'll get into the software servers and what they are. So the software servers are what basically attaches the API to software. So they provide access to software functionality, and they do this over the web through a REST interface. So you can think of a software server as something similar to what other applications, services out there that connect you to remote software. So stuff like Telnet, SSHD, VNC, if you know that, and remote desktop. They all connect a remote machine to remote software somewhere else. The difference between a software server and those services is that a software server doesn't try to replicate the native interface of that software. So Telnet and SSH replicate the command line interface for you on a remote machine, so you can access command line software. VNC and remote desktop obviously do command line, but do the GUI, so you can access the remote desktop and interface with the GUI remotely. A software server differs in that respect because it's replacing that interface, and it does it for everything. and it tries to place it in a consistent manner. So the idea is it's the same for every piece of software, and it's programmable. That's the main aspect of what a software server does. Is the interface it exposes is this REST interface, and also has a Java API, but it's a programmable interface. I could then write code that calls this interface to carry out functionality within that software. And the idea is here's that I can automate the software, something I can't do in Telnet or a remote desktop. Well, you could, but it'd be hard and messy. That's the main aspect of it. It's capable of being programmed against. It's also, through the REST interface, it's widely accessible across a number of programming and scripting languages because it's just HTTP. It's just a URL. And any number of languages support accessing URLs, making that API available like a library in a way to any number of languages out there. And it's a uniform interface. So the REST interface, again, is just a URL. So you would just go to a host holding a software server. You would go to a /software endpoint, where you would then specify stuff like the application you want to use, the task you want to carry out, in terms of conversions, the output, well, not just in terms of conversions, but actually anything, because it talks through files. The output format of the file that you that you're sending to it, and the input file. You would post that file to this URL, and it would actually carry out that task on that remote machine with that software. And the idea is also it's simple. It's nothing complicated, and it's easy to use for people to use. So getting into the software server and how it's implemented, there's problems with it, especially in terms of the, again, GUI applications. So the main problem is there's a diverse set of software interfaces out there for applications. There's a lot of different stuff. So there's, even in terms of these categories here, there's, of course, command line stuff, which are relatively easy to script. There's other programs that have macros and actually support scripting internally to the programs itself, like I think GIMP is one of those, which is kind of nice. So that's a little bit harder than command line stuff, but it's doable. Some of them provide APIs, which is nice too. And then there's stuff that have none of that stuff, which have just graphical user interfaces. So mouse clicks are the way you interact with those kinds of software. The idea is with the software server is we don't want to restrict ourselves to any one type of interface. We don't want to restrict ourselves just to easy stuff especially. We want to be able to incorporate anything into the software server. So I would say the hardest thing here is the GUI stuff, so that's kind of the thing we focused on, interfacing with GUI applications. So again, the characteristics of the desired interface is its main thing, programmable and consistent across all software, which is what that REST interface will be. And the one good thing about this is that all software will have some sort of interface. It has to, right? Otherwise, it's not usable. It's useless. So the idea is there's some sort of interface out there. Just you got to use it and adapt to it. So the approach we use here is to wrap individual units of the software functionality. So the idea is individual units being like open, save, import, export, whatever else is in the menus of a GUI application. And I support GUIs for sure, and make it consistent. And basically what the software server does in the back end is it's essentially converting all software into command line software through these wrapper scripts. So what it does is it exposes a new API, and what it does itself on the back end as well is it does a lot of management of the software. So it's kind of important, especially with GUI software and it's running on a desktop somewhere, is you have to protect the desktop. Because a desktop is doing, when you're interfacing with your desktop, you're doing one thing at a time. There's one window in the front that's active. And you got to kind of make that play nice. You can't do parallel things with a software server that are threaded because the windows are going to start interfering with each other. So that's something a software server tries to manage. It has to protect the desktop, make sure one thing is running at a time, make sure the desktop is preserved and clean, things are closed properly, dialog boxes aren't just sitting around popped up. So there's a lot of that in the back end that has to be managed. Protect non-atomic tasks. So there's some tasks that don't make sense being run by themselves. They have to be chained with other things, like an open save operation. Why would you just open a file and then leave it there? For example, if you don't do the save operation, some other application is going to come, some other software server request is going to come in between that and mess things up for you. Maybe close your application, who knows what. So it kind of has to protect those kind of things. And overall, maintain operation of the software server. Don't let the system crash. So that's something it has to take care of. So in terms of going back to the interfaces again, how do we go about scripting these interfaces to make them into command line interfaces that the software servers will use? So in terms of scripting command line interfaces, any scripting language can do that. That's not really an issue. Again, GUIs are the hard thing. So there's a number of ways to do GUIs. A lot of people know about AppleScript. AppleScript is a popular way of controlling software on Macs. They do require support from the software, though. So basically, the software built on a Mac supports a number of operations that they expose to AppleScript, and then you could then script those applications with an AppleScript, or what they call Automator now, I think. But that's an Apple thing also, and it requires software support. In Windows, there's a number of options. So there's AutoHotkey and AutoIt. AutoHotkey was actually derived from AutoIt. These are scripting languages for GUIs, and they kind of evolved, I think, to cheated video games. So basically, people write bots to basically do stuff on video games. But anywho, we use it for file format conversions here. So it's OS dependent. So it runs on Windows, and it knows how to talk to the Windows GUI, the Windows. And so, but the good thing about it is it has no need for software support. So basically, it's interacting with the operating system, Windows in this case. It doesn't care if the application supports it or not. And there's something similar to that on Linux called, I don't know how to say this, XME, I think. And basically, it's kind of like an AutoHotkey for Linux, same kind of deal, though. It's OS dependent, runs on Linux, but requires no software support as well. And then there's the more extreme case. This is a language out of MIT. I think it came out in 2009, called Sakuli. And it's actually a computer vision-based way of scripting GUIs. It actually uses screenshots of buttons, and it does pattern matching to find those buttons again and press them. So it's OS and software independent. It's written in Java. But it's got consequences on its own, which I'll go into. And so there's kind of trade-offs between each of these things. We support them all, though, in software service because we don't want to limit ourselves. So the idea is you can write a wrapper script for software that the software server will use in any text-based scripting language. So we don't restrict ourselves to any one of these. We use them all. The idea here is it has to be text-based, and it has to follow certain conventions. So the first are naming conventions. So, for example, a script will have usually an alias describing what that program is. So just a short name without spaces that kind of represent what that software is. It's just a way of connecting together different applications if you have separate scripts for them. So in this case here, like Adobe 3D Reviewer is the alias for Acrobat 3D Reviewer. And then an underscore followed by the operation to carry out. So in this case, open is the operation we're doing here in Adobe 3D Reviewer. And this could be like save and other operations like import, export, and so forth. And then these scripts basically take a number of arguments, and these are fixed. So the first argument is usually an input file, which includes the path name, has to include the complete path. The output file, also with a complete path. And a path, the third parameter is usually some sort of scratch space. So some scripts need to create intermediary scripts, and it uses that scratch space to dump them in. So an example of calling then Adobe 3D Reviewer's open operation through the command line interface some script would provide would be something like this, where you call that script, pass it these three parameters, and it would actually carry it out. Open operation opens up this file, and then if it did more, save it to this other file using this scratch space if needed. And so that's the naming convention of these wrapper scripts for the software servers. The next convention is the header of these files. So they're all text-based, and they're all scripting languages. Scripting languages have ways of commenting stuff out. They just do. And so basically the first few lines we required them to be comments containing certain amounts of information, such as the pretty name of the software, in parentheses, the version of that software. This is used for indexing later on, that software. The type of data it deals with, so like 3D image data, something like that, just so the software server and Polyglot can kind of bunch these together later on, say, oh, this is all for 3D software, this is all for image software. And then the next line, commented out line, is the comma-separated list of input formats represented by file extensions. We use file extensions just because they're easy to deal with. So it's just a list of those. And then a comma-separated list of output file formats that it supports. So some scripts use all four of these comments, some don't. So like obviously an open script won't have the last one because it doesn't do output formats and so forth. So there's a number of operations. So there's stuff to deal with inputs and outputs. Open, save, convert is kind of an operation that does both the open part and the save part. So some applications like ImageMagick do both of those things. Maintenance operations. So these are the things that the software server uses to help protect the desktop. So stuff like how to exit the application cleanly. Scripts that try to monitor commonly occurring events in the application. So like this dialog box keeps popping up every time I do this X. So kill it. So a monitor script can be written to kind of take care of that kind of stuff. And a kill script, so a way of actually killing the application a little more elegantly than just killing the process, which the software server will try to do too if it has to. So you provide those kind of scripts as well. And then there's a modify operation, which kind of tries to encompass everything else that's not encompassed up there. So stuff like in between an open save operation, do something to the file, and then save it back out again. So it's a way of kind of capturing other functionality within software as well. So basically, I went into that, and stuff that could kind of go into modify operations, stuff like in an image software, like blurring an image, running an edge detector. In a 3D software, maybe something like decimating a mesh to make it smaller, changing a font in a document or something like that, printing stuff, who knows, making pie charts and spreadsheets, stuff like that. So stuff you would modify the data once it's open in the file and then save it back out again. So in terms of managing the software, what a software server does is it, again, tries to hide direct access to the software itself, because some things just don't make sense on their own. So like the open operation doesn't make sense by itself without a save operation. So it hides the direct access to these scripts and those direct operations, and tries to bunch them together in ways that are atomic, so they can be run on their own. So for example, there's a task which we identify as convert, where it can either be made up of scripts that do the convert operation, or two scripts that do separately the open operation and the save operation, and just sticks them together. And then there's a modify task, which again, there's modify scripts that do both opening of files and saving of files, or it could chain together a number of operations that do them separately by opening a file, modifying the contents of the file, and saving the file together. So basically, a software server just exposes these two tasks at the moment, I think, hiding the underlying operations within them. And again, I emphasize this here again, is these operations are wrapped around by open save operations, because that's the main means software servers use to communicate with the outside world, is through files. So you pass it in a file, something happens to the file, you get a file as output, and that's basically the input and output to that. So in terms of the management that the software server does, there's the monitor scripts. Basically, again, as I mentioned, they monitor the state of the desktop, look for rare events, and deal with them. The exit script, which basically, if you have an application that is not very reliable, which I have had to deal with, you then include an exit script that kills it after every task. So after every open save operation, if there's an exit script, it'll call this exit script, basically closing the application, just trying to give it a better chance of surviving the next task. So there's applications where I've had where you can't do two in a row. So basically, you kill it every time. So you include an exit script. There's in the configuration of a software server, you could specify how long any task can take. By default, set to 30 seconds. If that time is exceeded, it assumes that the program has crashed or is not responding, and it'll call the kill script at that point. And that's where things are getting kind of bad, and this desktop is potentially unstable. Worst case scenario, you can actually, within a software server, reboot the machine. It's a cloud-based service, so ideally there's multiple instances of that machine out there, but that's the last resort. And so overall, the idea here is to protect the state of the desktop to make sure that things can keep on running. So again, the main interface that the software server is exposed is this REST interface, where everything's exposed as URLs and has this, again, this form of application, task, output format, and you just post something to that URL, and stuff gets executed on the remote machine through the software servers, which are calling these scripts, either AutoHotkey, AutoIT, Seculi, whatever. So in terms of scripting, I just want to go into a few of the scripting languages we do use. And the main one, for those of you who have worked on Polyglot, have already done this, is AutoHotkey for the GUI scripting stuff. So you can call command line stuff within AutoHotkey. So sometimes it's kind of convenient just to stick with one language and deal with even command line stuff in AutoHotkey. But the thing it does is, again, GUIs. So what it does is it uses the message passing system behind Windows. And if you don't know this, Windows uses a message passing system. So every button, every menu is actually an instance of an inherited instance of a window element. And basically, it's just modified. And the way they talk to each other is by passing messages around. And so a window will send a message to another window. And what AutoHotkey does is it kind of saves and repeats those messages between the windows. So you can use tools. It comes with one called AutoIT Windows Spy to kind of intercept some of those messages. There's a nicer one, which I don't know if it's supported anymore, called WinSpectre Spy, which lets you can interact with a window, and it'll spit out all the messages that are coming out of that window. So you can then use that to keep track of the messages and then put them in your scripts to actually control that GUI in the future. So some care needs to be taken with regards to dialog boxes that may appear, and I'll mention a little bit more about that. That's kind of the tricky part of dealing with GUIs, is there's a lot of unexpected stuff that happens in terms of asking for user input that you have to kind of deal with. So here's an example AutoHotkey script. This one's for Adobe 3D Reviewer to carry out an open operation. So it's fairly simple once you get used to it. So basically, it has this command up here where it says if the window doesn't exist with a title Adobe 3D Viewer, do something. It's an if statement. So the next command inside of that if statement is run, which is just basically execute some program, in this case, Adobe 3D Viewer. And then the next command here just says wait until there's a window that appears with Adobe 3D Viewer as its title. So basically, this is how you start up the application before you actually do anything. So the next set of commands is kind of like making sure that window is actually in the front. So activate that window with this title, and then wait for it to be activated. And then actually you can start doing stuff with it. So in this case, press the open button in the menu. So file, go to File, Open. So in Adobe 3D Viewer, I used in this case Inspector Spy to find this number here. This is the message to Adobe 3D Viewer. That's the Open menu in the File menu. So by sending this message here, I actually click on that button effectively. So then the next command waits until the open dialog box appears with open as its title, and then it sets the text of the first edit field with the first input argument, which is the input file. So it basically sticks it there, and then it sends a command to that edit box of enter to basically open that file. And then there's some more stuff down here that kind of makes sure the file actually opened, and this is kind of some of the tricky stuff that you have to do in order to make things just work. So that's an example of a GUI script for a GUI application. So in terms of command line stuff, it's pretty trivial. Again, the important thing here for auto software service is the header in the comments here. But for command line stuff, you can just basically call this command run wait, that argument with the parameters, and that's it. Basically, all you're doing here is wrapping this header here so that the software server knows how to use that software. But it can be written in any language. It doesn't really care. Some applications that have GUIs also have headless modes, which is kind of nice. So you can do stuff like with OpenOffice, for example, you get it as a headless option. So you can run it as a command line kind of thing, open a file, and then save it to some other file as well. So that's the kind of things you have to be aware of. So if you can go through some non-GUI interface, it's important to do that just for robustness sake. So when dealing with scripting, though, one of the important things to keep in mind, though, is timing. So there are probably the biggest headache when dealing with GUIs is timing issues. So the idea here is, if you're in your script, you have to make sure you don't click on stuff before they actually appear on the screen. And so that can sometimes actually happen. And the main problem here is that GUI interfaces are designed for human beings, and human beings have eyes to see with, and they don't click on things until they see them. But the script doesn't do that. It just says a bunch of stored commands, messages, and just spit them out unless you tell it to carefully wait for things, if you can. So for example, just Notepad here, you're clicking on the file, you want to click on open. You want to then open some file here, you type something down here and press the open button. A little auto hotkey script to do that could look something like this. In the trivial sense is where you just basically select a menu item, this time by the text there. You don't have to do the message sometimes. You can just use the text in the menus. So in Notepad, press File, press Open, send the text to the edit box, and then press Enter to do this. And if you're not, the problem here is that if you're not careful, it's a computer. It's going to try to execute this quick. So it's going to go within a fraction of a second and execute all these things. The menu won't be open yet. So the open dialog box won't even be there, but it'll click something, try to click something, and weird things are going to start happening. So you have to be pretty careful about that. And the idea here is that basically, again, a human sees. A human sees the file menu, and then if he wants to click the file menu, he waits till he sees that before he actually presses it. Then he waits to see the open menu before he actually presses it, and then he presses it. Waits to see the dialog box before he presses it. Waits to see this before entering stuff, and then waits to see that before he actually clicks it. So that's where the vision-based scripting languages are actually kind of neat. So they use computer vision to try to do it kind of like a human does. When you see a certain button, click on that button. So it avoids the timing issues. It has other problems, but it avoids the timing issues. And basically what it does is it uses screenshots of buttons, and when it sees that button, by doing some pattern matching on the desktop several times per second, it clicks on those buttons when it sees them. So this is an example of Sakuli. It's a scripting language that came out in 2009 out of MIT. It's based on Python. It uses JPython, and it's written in Java, and it uses the Java robot class. If you've ever played with that, it's a neat little class that lets you interact with GUIs. It basically the mouse, I'm sorry, and it lets you move the mouse around on your desktop and click on things. So it uses the Java robot class to actually carry out the clicks. So basically, this is a Sakuli script here. So again, it just to open the application. In this case, this one's for Notepad. Simple example. It just calls the program directly to open it up. That part you kind of have to do that way. And then it basically has this nice little IDE with it as well that makes it easy to get these screenshots. So basically here are all the commands you have, such as click. If you click on the click over here, it fills it in your script here. and it automatically opens up, it hides this menu and lets you draw a box around something on the desktop, and then press something, and then it sticks that picture there. So it saves the picture into your program. So it then knows to click on this file button, click on this open item, type something into this thing that has text there, the edit box, and then click open. So it basically carries out that GUI operation by pattern matching. It's finding these sub-images within the desktop as they appear. So, but because it can see, it doesn't suffer from the timing issues of AutoHotkey. The downsides are, though, it is relatively slow compared to AutoHotkey. It has to do this pattern matching. So basically, it's basically moving a little sub-window over the entire desktop several times per second, comparing the contents to see if it matches. That takes a little bit of time. It's also dependent on your desktop theme. So if you write a script on one machine and try to move it to another machine, it depends on, if it's the same default desktop, that's fine, I think. But if you change the fonts, change the backgrounds, change the borders, change the colors, it won't work because it's looking for an exact match. And so that won't work. And the current version uses the IDE, although I did see a paper where they try to automate it in the sense that you could just do an example run of clicking through a program and it would record that. But this was a few years ago, and I don't know if they actually did release that as a tool yet. So anywho, we at the time weren't around the exact same time actually. Weren't aware of Securely, and actually we're trying to make this ourselves as well. So we called it monkey scripts, monkey see, monkey do. And the idea was that to basically let somebody just click on an application and then record it in terms of what are they clicking on, and then repeat it later on. So the way it did it, it was really trying to let people do a demonstration to run through the program and then record that. And it was a little tricky to do on the same desktop that you were actually running on with Java. So the way we ended up doing it was through VNC. So we basically used an open VNC implementation to type VNC. And what you would do is then VNC into a remote desktop, and then basically, since you were in Java, had a window to that remote desktop, you could do whatever you wanted. You can intercept mouse clicks, take screenshots, whatever. So it made it easier in terms of recording stuff. So an example of that here with Monkey Script was I'm VNCing, remotely connecting to this remote Windows XP session. And the way you would start it is you basically I think it was Control, and then you would right click, and then it would open up this extra menu that wasn't actually there. And then you can basically start creating a script. So you could pick what kind of script you wanted and open, save, convert, exit script. And then you basically, again, like Securely, you have to run the command before you can actually do any stuff. So you basically, in the menu again, click next step is run the command, in which case it would pause the script. You would do whatever you needed to do to actually execute the command. You'd have to enter where that command was, then press OK, carry out that command, and then you would right-click and do control right-click and do resume script, in which case it would start recording again. And so then you could do stuff like do your control click and select target areas to do stuff in. So for example, if I wanted to start recording mouse clicks on an application, I need to make sure that application is the same size every time. So what I do as a first step in this script is maximize a window. So in this case, I'm selecting a target area that it's going to click on. In this case, I draw a little box around the maximize button here, so it'll do a pattern matching kind of thing to find that. And then I click on it, and it's recording that. And then I can do other stuff like click open here, in which case now it's recording the coordinates of the click, so it'll repeat that later on. And it also records a screenshot of what I clicked on, so it knows to click on that as well. And basically, you can do stuff once you get this dialog box here. You can start passing in arguments. You kind of have to tell it to do that through the script. So again, you do the control click and say, I want to insert argument 1 here into this dialog box. You do that. You then actually have to find some file to actually on the ad machine to actually carry out the rest of the process with. So it pauses the script. You do that. You click resume the script, and then you continue clicking open, and then you're done, and it spits out a script for you. So the monkey script kind of looks like this, where it runs a program. Target image was that maximize button. Clicks to this coordinate. The desktop should look like this after you do this. So that's an image, and so forth and so forth and so forth. So that was it. That was the script. So that was one attempt. Securely beat us to it. So anywho, we didn't publish that. But the next thing we tried doing also was using AutoHotkey to do some of this vision-based scripting as well. So AutoHotkey actually does support pattern matching. So you can actually give it an image, and it'll try to find it on the page on the desktop and do something to it, click on it and stuff like that. But there's no nice IDE like there is on Securely, where you could just take those screenshots, or like we tried to do in the monkey script, where you could just take little drag and drop a screenshot and stick it into your script. So what we did is we decided to make an Eclipse plugin, and we called it HK Clips, that basically kind of did that for you. So it's a plugin for AutoHotkey, and so it does the usual text highlighting for AutoHotkey. But the nice thing is when you do the image search command, which is the AutoHotkey command for the image matching, it brings up it basically, well, it doesn't bring up anything. It minimizes the eclipse, brings up this little window here where you can then drag and drop and put it on top of some button you want. So you can, like the open button here, click on the transparent capture on there, and it'll take a screenshot of that and stick it into your code. This is just a preview. It's actually this file here, test.jpg here. And so that's basically how you can use the image search commands in AutoHotkey to do some of that vision-based scripting there. So that is still kind of evolving. It's a little buggy, but it works. It's functional. And so that was kind of the idea of trying to get the best of both worlds. So when you can do kind of get the speed of AutoHotkey when you can, and the robustness in AutoHotkey when you can in terms of finding buttons with text in them, and when you can't, using the Seculi stuff to kind of deal with timing issues, the image-based stuff to deal with timing issues and stuff like that. So that's kind of where we were in terms of scripting. We developed a number of tools to help in the scripting process. One of these is called the script debugger tool. What it does is it automatically tests the functionality of scripts. So when again, I can't emphasize this enough, scripting GUIs is really error prone. So you have to be diligent in terms of your testing and what you do to make sure things don't go wrong. So the script debugger tries to help you with that. So it tests the functionality of scripts using a small data set. So basically you give it a number of files, 5 files or something like that, and it tries to grind that script, running it over and over again with those files and just seeing if it keeps going. And it reports to you back how many times it failed, how many times it didn't. And you can use that to decide if I need to improve that script or not. It also does stuff like configuring the script to run on a local machine, on your machine. So a script, especially if what it does mainly right now is the command in there to actually execute that program is hard-coded in there with the path. If you put this on another machine where the path is different, it won't find that program, obviously. So it'll find those lines inside of a script and basically search the local machine for stuff that matches the executable and fix the script and correct that. And so basically that's what the script debugger does, and it should do more than that in the future in terms of making more robust scripts. I would hope so. And then another tool called the script installer. So what this does is it basically tries to, so the idea here is you make these scripts once and never again. And the idea is that you would store them somewhere in a database or a registry, and that actually was what we did do. We created this thing called the conversion software registry where these scripts would go, and if you ever needed them again on a different machine, you could just get the scripts there and not have to rewrite the AutoHotkey script or whatever else script from there. So what the script installer would do is it would search the local machine for all software on it. On Windows, this could be done like through the registry, and then go towards this conversion software registry and query it for all the stuff that matches that. And then basically what it does is it downloads the scripts that match, and it actually calls the script debugger to configure it for the local machine and possibly even run tests to make sure it runs properly on that local machine as well. So here's where I take the first tangent and talk a little bit about just briefly about the conversion software registry, which came out of this as well. So the idea here is with the conversion software registry and why we made it is that there is a lot of software out there, and a lot of file formats out there, in terms of with unique capabilities in terms of opening and saving files, what file formats they support. And the idea is how can somebody identify what software they need? So I have this data, I need to convert it to this. How can I find the software that I need to do that? So the idea is this Polyglot, this software servers, will automate software so that I can do a large batch process of migrating files to one other file format. But I need that software in the first place. How do I tell which software do I actually need? So this registry kind of does that. And it kind of complements other registries out there for like file formats. There's one called Pronom, which basically tries to list all the file formats out there in the world. There's another one called UDFR, which does that as well. And this is different in the sense that it's not indexing formats, it's indexing software based on the formats they take as inputs and outputs. So if you go to this, so basically all it cares about, it's not the applications, but what it can do. So it takes all that away, and all it cares about is what formats can you open, what formats can you save, what formats can you import, what formats can you export, where can I get the application. So basically it's a database and it's a mess, but in a nutshell what it cares about is the software, and it has entries for stuff like what kind of interfaces it has, what platforms it runs on, what license it has, where you can download it from, what kind of formats there are. So it does keep track of formats. We do link to other databases like Pronom, so we don't replicate a lot of that stuff. And then the key thing here is the conversions. What formats does any piece of software take as inputs, and what formats does it take in outputs? And we also store the scripts here that I mentioned before in this database as well. This is actually a way we can populate the software and the conversions in the scripts by basically mining the headers on those scripts that get stuck into here. So we just upload a script in there, it reads off the header, and it says, oh, application X imports X, Y, and Z and saves A, B, and C. I'll add that to my database. So this is what the conversion software registry looks like. Basically, if you go here, the idea is you index it. It's indexed based on formats. So I don't know if you can read that, but I'm typing in OBJ as the input format, STP, which is step, is the output format, and basically what it's, boy, this is really grainy. But basically what it's giving is a list of software. This is a 3D object converter and Adobe 3D Reviewer that do that conversion. It also does chains. So the idea is, well, are there more things I can do if I allow for an intermediary application or an intermediary format? So if I convert from the original format to some other format and then from that format to the target format, is there more ways I can do this? So you can specify, well, allow for one intermediary format, and then it'll tell you what software applications you need for that as well, based on its database. So the way it does that is it builds a thing called an input-output graph, and this is kind of the small workflow I mentioned it before. That's was part of the original Polyglot. So the idea here is an application, as far as it's concerned, is just a bunch of opens and saves. And so what an input-output graph looks like is basically a little graph here where all the vertices are file formats which are referenced by their file extensions. And the edges here are directed edges that represent software that can convert from a source to a target file format. So this is for just this one application, Adobe 3D Reviewer here. And so if you do, you can stick multiple applications together, and you get a much messier graph like this. But you can do stuff in it, like look for a shortest path between two vertices, two formats, and get a chain of applications that can carry out that conversion, the shortest chain. So the idea here is there is no shorter chain in this particular, with these particular 10 applications here. No application can go from step to X3D according to these 10 applications. But you can do that by going through these 3 intermediary applications together, chained together. So that's what the conversion software registry does in the back end. It basically builds that graph based on its database and does that graph search when you type in something here and type something down here, and returns to you the results in terms of what matches that in the graph. So this was just, I think, a bigger example in terms of more results, but it also lets you see the graph as well. I don't know how well my videos are going to do if they look this grainy, but the idea here is that you can actually explore this graph at the conversion software registry. So if you do go to the site and you click on graph, you can see all the software listed here on the left here, which is a lot. I think we got 2,000 some applications or something like that, I think. And basically what you can do is click on a number of them, and what it does is it'll automatically fill in this graph here on the side, and then you can click on multiple at the same time. So you do a control click, and what it'll do is basically add that other application's vertices and edges to this graph and kind of build it up for you. As you do that, I'll maybe just click on one more. So it basically added a bunch more vertices and edges. And so then you could do stuff like within this graph is click on stuff, like you could right-click on one of the vertices and select it as source, and then right-click on another vertices and select it as target, and it'll do this graph search and show you the path within the graph that it has to hop across, and spit it out here at the bottom so that you can see what applications are actually involved in that. So you can actually, as an archive, for example, select, well, I have these, all I have are these pieces of software. So what conversions can I do, for example? And you can determine that through this graph. You can also determine what software you need to obtain, what software you need to purchase if you want to do more conversions as well. So an example here is just showing you the conversion path for that. You can do other things as well, such as what am I showing here? No, I'm going to skip this. So you can do other things as well, such as you can see stuff like search what are all the formats, given these applications I select here on the left, what are all the formats that I can get to from OBJ. So it'll show you in this case what we call the range of that format. And basically these dark arrows here indicate all the formats I can get to from OBJ. You can also do the domain. So basically, if OBJ is my target format, with these applications selected here, what are all the formats that can get to OBJ? So in terms of an archive, this is kind of the tool you would use to determine what the possibilities are in terms of your potentially ideal format. You could do stuff also like what we call the working set, where you basically, well, my archive contains all these different types of files. So I would basically select a whole bunch of them and add them to, in the menu, what's called the working set. And then it'll spit out all the formats here that can be reached, in the union of all the formats that can be reached from these formats that you select. So you can see, well, these are all the possible formats I can convert all these different files types too. So again, just another tool. And so you can do other stuff in here, and you can search the software that's in the database. You can search the formats that are supported in the database according to the extension, according to the MIME type for the ones that have indicated MIME types, and according to the pronom ID. Again, the pronom is a database about file formats that we leverage and kind of complement. And of course, you can add stuff to the database as well, either manually or through a script that you upload to it. But anywho, so going back to the software servers and how that links to the CSR. So the idea is that the scripts get stored into the CSR. So all the scripts are there, potentially. And the idea is with this script installer command, what you would do is you can run from the command line like this, and you specify a method to search your local machine. In this case, reg means search the Windows registry. And then what it'll do is then look through the Windows registry for all the applications it finds, go to the CSR, the database, look for all the ones that have scripts where the pretty name in the script matches somehow through some string matching what was in the registry, and then download those scripts. And you can also specify stuff like stuff for the parameters for the script debugger in terms of testing. So when I download this script, also test it 5 times to just make sure it's running properly on my machine. And it'll actually download data from the CSR as well, because we do store some sample data in the CSR for this purpose of testing software server installations. So in this case here, I ran this command on this particular Windows instance, and it downloads all these software scripts, so some for Acrobat, for Blender, for GIMP, for Google SketchUp, ImageMagick, and so forth. And then what it does is it runs the script debugger to actually configure them for the local machine, changing paths if need be. So like this case, Blender had some hard-coded path that didn't exist here. So it searches a number of directories on the local machine, and it finds a match here. And we made it so you manually have to select which match to find, because there are some danger areas. So for example, ImageMagick has convert.exe as its command that it executes. Windows also has a convert.exe, which converts the format of your hard drive. So you don't want to accidentally call that. So basically, we let you select here which one to pick, and then it sets it in the script. And then it shows you what files. So since I put -test5, it downloads 5 test files for these scripts. And I think it looks into the script in terms of what types of data is stored. So it downloads data according to that. So 3D data for the 3D scripts, and image data for the image scripts. And basically, it runs these tests. So it runs it 5 times, because I said to run it 5 times, and it sees success, success, and it basically counts them up. And so success 5 out of 5, so that's a good script. Some of them don't, some of them fail. So success in this case was 0 out of 5. So it drops that script. So within the scripts folder on the software server installation, it has this little file called aliases.txt, which stores the aliases of the software scripts that it has. And basically, it comments out the ones that fail the test so that it ignores them, essentially. So the ones that are left behind are the ones that were successfully tested and run on your local machine, and will be available through the software server. So what was kind of cool was that with that setup, with the CSR, the script debugger, and the script installer, it actually made it so you can really easily install a software server. So basically, what you could do is we do a simple 2-click setup with a little installation that comes along with the software server. Basically, it'll modify the registry with these 4 lines. You stick it in a .reg file. It modifies the registry so that it adds a menu item to the shortcut links. So basically, when you right-click on a shortcut, you'll see this share functionality menu. And what it does is it calls this batch file called share.bat, which is basically 3 lines, which calls the script installer, which basically passes in a shortcut, whatever you click on, and its name is the argument, and then runs a software server. And so what it does is you can click on an application on your desktop, click share functionality, it'll call a script installer, query the CSR, get the needed scripts, configure it for the local machine, possibly test them, and then start up a software server, and the software will be available through a software server. And so I'll show this video here, basically what that looks like. So in this case, this is Windows XP. We initially started with Windows XP, but we're supporting Windows 7 now. So it's hard to read, but that's share functionality for Microsoft Word. It's calling the CSR, downloaded the script, starting the software server, and here you can see, if you can read it, is Adobe 3D Viewer. It found it and is running it. So what this looks like, so remember, this is exposing a REST interface and a Java interface, but a REST interface, which is just a bunch of URLs. So you can actually go to that software server's hosts, that Windows machine's address, on port 8182, and you can see it. It'll present itself as a little form, and it actually, through the script installer, it takes the icon too and just sticks it there. So you can click on that, and it presents a little form that exposes the functionality of that script. So in this case, for this one, it was just a convert operation to convert task, and you can actually call it from this form and execute stuff. So you could paste a URL, or you could do a post to this URL too, and carry it out by just doing a browse on your file system. Specify the output format, and then click submit. It always shows you the REST command here because that's the main way your intent for using this stuff. And what it's actually doing is it's executing it on that remote machine, and it returns to you a link where you can download that file after the fact. So if you go to the remote machine, you can see what happens there. So here's that software server running, and it receives that request. Basically what it'll do is it'll open up the application, carry out the mouse clicks. It happens pretty quick, but not too quick, so not to mess anything up. And it saves the file in that other format, and it's done. And so what you can do then is add more applications. So basically you can go back to your start menu. In this case, I think what I add? What was the first thing I added? Oh, Adobe 3D Viewer was the first thing I added. So now I'm adding Word. So it found in the CSR 2 versions of Word, so it asked me which one do I want, 2007 in this case. So there we go. Now it's added. It's listed there as well. So basically when you do a script installer after you've already run it the first time, it kills the software server, downloads the new scripts, restarts the software server. So now I'm adding Blender. Right-click on that. Share functionality. And basically here, in this case, like I showed you previously, it doesn't know the script on the database. It has a hard-coded path that doesn't exist on this particular installation. I think it was something to do with 64-bit versus 32-bit. So anywho, it's basically searching the file system now for where that script is, and then I'm not going to wait for it. It takes a little bit to search that file system, but once it finds it, it sets the script. Oh, there it goes, and it's done. So it's available there. Blender is available now as well. So if you go back to the browser and you refresh your page of the software server, now you see all those things suddenly appear. And then you can carry out whatever operations are available on those now. So I wanted to show a GUI one. So here with Word, it has the convert operation. The scripts only support convert there. And so basically I specify a file. This is a simple little text file with just, I think, hello world in it or something like that. And I want to convert it to a doc file, so I specify that and then click the submit button. So on the server, what that looks like, to actually get the request, open up Word, open and save it, kill it, done. So it basically carries it out so you can then download it from the URL. But again, the main thing is the idea is that REST interface is not to be interacted with the form, but through another program. So you can do a lot of different software, and so this is in a case where I clicked on a bunch of different stuff, and you go to the web browser there. On the form, it actually shows you the resources available on that server as well. So in this case, it shows you that machine has 1 core, and the ping time is 5 milliseconds to give you an idea of what the latency is to that particular software server. The idea here, again, is this is a distributed, I don't know if I mentioned this already, but software servers are a distributed resource. So the idea is there's many of them, and it's kind of a cloud thing. So they come and they go. They have different software. They're running on different machines, different platforms. And something, Polyglot, later on, will stick them all together to do conversions. So again, the idea here is the REST interface is what's important. So if you go to the /software endpoint, it'll give you a list of the software that's available on that particular software server instance. If you go to one of those applications, it'll tell you what tasks are available in that application. So in this case, just convert. If you go to that task, it'll tell you what output formats are supported by that task and give you a list of those. And if you go to one of those output formats, it'll give you a list of all the input formats that are supported for that particular application task and output format. And again, the idea here is programming against the software, so you can automate it and run large batch jobs on your archive to get to some other file format and do these experiments to determine what the best file format is for you. So this is a simple bash script, which kind of I was hoping to try to show how easy it is. But most of this script is just a bunch of variables. So the first one is just specifying the host, the application, the task, the output format, IGES is a 3D file format, input, which is a step, is another 3D file format, and sticks it all together here into the REST endpoint. And then it's basically a for loop, which goes through some directory of the particular input type, step file formats, and then the idea here is to convert all those files of a step format to the IGES file format. And it does this through a software server. So basically it uses the curl command, everybody should know the Unix command curl, to post the file to that URL endpoint. And once it does that, it uses the wget command. So it has to loop through this because it takes a while. It checks for, is it actually done? Does the file exist? And when it's done, it actually uses wget to download the result and stick it in the local directory. So basically, it's using the software server to carry out conversions on a little directory. And so this is the idea. The idea is you write programs that automate these, use the software servers to carry out conversions. So software servers also support authentication. Obviously, you don't want to let just anybody access your software or your machine. So in the software server, you could specify users and passwords. And the way you would then interact with the REST interfaces by in the URL, you could specify these things as username, password at that particular host, and then the rest of the endpoint's the same as before to actually carry out your task. There's also a Java API to the software server, so it's fairly simple. So the way, this is getting into the code part now. So basically what you would do is there's something called a software server client class. So you would declare one of those, and when you instantiate it, you would call it with this constructor that indicates what the host is, the IP address of the host or the name of the host, and what port on the host to connect to. And so that's all it takes to basically get to connect to the software server. Then you could query it for what applications it has. It's just a vector of these class things called an application. You get that from the software server, and then you can then print them out and see what applications it has there or do something else with them. But then to actually do stuff on the software server, you would bundle what you want to do into these things called tasks. You would create a task list where basically when you specify the task list, you specify the software server the task is to be carried out on, and then you basically build the task according to application, operation, input, output. And so you could chain together a bunch of those, actually hard code them into some application, and then execute them, where the parameter here in the execute is the output directory to dump whatever results come back. And this, when you call this here, it actually executes it and waits for it to finish, and then you can close the software server and exit. So basically that's the Java API for the software server part of this. The software server client also has a main class. So if you were to just call it directly, it would actually execute in a command line interface. So you can actually do stuff through the command line, like do an ls to see what directory you're in on the local system and see what files are there. Then you can build a task by calling the task command, where you can start building a task. The first thing in the task could be something like calling Blender to do convert on this input, on this output. And you can chain together a bunch of things this way, same way, application, operation, input, output. And when you type in end, it actually carries those out and pauses there until it's done. And then if you do an ls at the end, you can see that it did this conversion essentially by chaining together these applications to get this VRML file to a step file. So what we've done also is we've taken these software servers and included them into a scientific workflow. We've already talked about scientific workflows and how they're important in cyber infrastructure. We also talked about Cyber Integrator, which is our workflow system. Chris Navarro actually did this part of it here, including software servers into Cyber Integrator, which I think is a unique aspect of Cyber Integrator, in that I don't know of any other workflow system that does GUI software. So scientists use GUI software. It's part of their workflow. Yet most software workflow systems that I know of have built-in tools or call command line scripts or stuff on remote supercomputers and execute those things. But so we decided it'd be kind of a nice thing, well, if we added software servers and call any application potentially running on some machine somewhere. And so Chris made it basically so you can, there's a little dialog box here where you can add a software server to your workflow. So you can basically specify the URL of a software server, and then what it would do is it'll look for a number of scripts on that software server, applications in the inputs and output file formats that they support on that software server. One caveat that, as Chris discovered, was that Cyber Integrator is based on MIME types and software servers are based on file extensions. So one thing that you have to do is kind of specify MIME types for things that it doesn't recognize. So that's kind of the next dialog box here, is where you specify the MIME types for certain formats, which you can do here. But then once you do that, you can actually add individual tools on the software server as tools in the workflow. So in this case, he's adding Adobe Video Viewer, CyberWare's PLY tool, ParaView, and ImageMagick to his workflow here. And then he creates a little workflow which does a conversion, which using ImageMagick in this case, which is a command line tool. But nonetheless, it shows you using a software server to convert this JPEG into a PNG file. And you can do it multiple ways. So one of the main aspects, which I mentioned already and reiterate again, is the robustness of these things. We're using GUI-based software in an automated manner. Things do go wrong a lot, and things fail. And that's why the soft script debugger exists, to kind of grind the script, and why you have to take care in writing your scripts, and why there's vision scripting and AutoHotkey scripting as alternatives. It's tricky sometimes. And so one of the things we looked at initially was how robust are these things actually in actuality? Can you actually rely on these things to be services to actually do useful stuff in a batch mode for an archive, converting all their files to another format? And so we actually wrote a paper around this of trying to see, is this actually a reasonable thing to do? So what we did, and I throw this in here because it did okay, Basically, we try to deliberately break the software servers, make them fail, and see what kind of throughput we could get out of them. How many files can they handle per second, for example? Is this something worthy of a service using these GUI applications? So the way we did this is we had two experiments. One where we had a database, a collection of files in different file formats that we would pass to the software servers and just send as many as we could and see how quickly we could get results back and record that, how many tasks per second it could carry out. That was one case. And the other case was where we, kind of an adversarial case where we were deliberately trying to break the system. And the way we did that, tried to do that, was we took the files and changed their file extensions. So basically, a JPEG file we could change to like a spreadsheet, an Excel file, or something like that. So the application that would get called on the software server would be totally irrelevant to the file type. And so some weird would happen. So it would try to open up, like a document file, would try to open up a 3D model because it thought it was a document. And some software handled it, and some software did weird stuff. So that was the way we would try to actually break the software server. So then weird things would start happening. The software server monitor scripts would kick in, the kill scripts would kick in, and the stuff would just start going downhill. And the idea was, would the software server be able to recover? Would it come back up? So sometimes this would involve reboots, actually. So it would reboot the machine. How does that affect latency and stuff like that? So we did an experiment with 10 applications here. Some of them command line stuff that were easy to script. Some of them that are heavyweight software like 3D Studio, which are hard to script. And we ran this on, I think, several VMs. But each VM had one core and 1 gig of memory. And the idea is we measured the throughput. So in case one, where the files were friendly, we were able, on average, to get 1,300 tasks per hour, which is not bad considering what you're doing with GUI-based stuff. And with the average wait time about 4 seconds for a task. In case two, where we were throwing at it bad files, we were able to get 945 tasks per hour with an average wait of 11 seconds. And so the important thing here is it didn't crash, which I was thrilled by. But the wait time increased because it was calling monitor scripts, kill scripts, rebooting machines when things went wrong. But the idea here, the important thing is it stood up. The software servers recovered. So going into this a little more detail with regards to the command line stuff, which is kind of like the baseline because they're the easy stuff to script. How fast can they run? So like Image Magic command line program, it got to about 1,800 tasks per hour. UrbanView, it has a GUI, but it also has a command line interface, was able to get up to 3,100 tasks per hour. And then we would compare that against GUI software. So like 3D Studio Max, which is a heavyweight piece of software, 355 tasks per hour, much lower than those command line stuff, and Microsoft Word at 756 tasks per hour on average. But the thing to keep in mind here is how many people would it take using the software manually to get this kind of throughput. The idea is the important thing here is for an archive is it's automated. It's just a script or a program that's actually running through your entire archive doing these operations, so you fire and forget and just have it carry it out. So beyond that, we've been working on actually adding parameters to the software servers as well. So initially, there was no parameter support. So a lot of programs have parameters that go along with open and save operations. And the way it deals with parameters now is they're hard-coded into the scripts themselves. So if you have parameters to set, what you can do is create multiple scripts, one with a different parameter for the save operation, for example, and kind of have a number of scripts through the various possible parameters for that. But it's not particularly elegant, so we worked on actually adding parameters to the software servers as well. So an example of that here is saving a JPEG file in GIMP here, for example. An obvious parameter for JPEGs is the quality of that JPEG file. So right now it's hard-coded into the script at some value, 85, for example. So it would be nice if you could set that. So in other applications and files, it gets much more elaborate. Like UrbanView here, saving as a PNG file, there's a whole hierarchy of menus to go through in terms of parameters that you can save that with the save that file. So basically the idea was to modify the scripts used by the software servers that support parameters. So going from this to something like this, where you would specify parameters and values along with it. Liana was actually the one who did this work. And so what we ended up doing was modifying the headers. So we added this first line is now, if it exists, specifies the format of certain fields in the header. So to be reverse compatible, if this isn't here, it's by default just usual stuff as before with the comma separated values. But you could, if it is here like JSON, it indicates that the parameters down here are specified as JSON. So a Java object representing an array. So like the software parameters in this case are also a new thing where they're the last line in this header and they specify the parameters of that operation for image J in this case, for images, for conversion with JPEG to one of these possible output formats. These are the possible parameters that could go along with that for each particular output format. These are the parameters. So this is obviously pretty bulky, and it gets very bulky actually, but nonetheless, that's supported in the software servers and in the scripts now. We also had to modify the CSR in order to accommodate this. So now there's a parameter table in the CSR, and this parameter associated with conversions in the CSR. Rob actually did this here, where he modified the input-output graph so that when you click on a source in a target file format, it actually shows you the parameters available. So remember, each edge is an application that does that conversion. These are the parameters that go along with that down here. And Leon actually made this tool then to make it easier to make those scripts. So those parameter portions of the header file are obviously very messy, and you don't really want to do that manually. So she made this nice little tool that basically records those parameters as you go through a demonstration run of an application, and uses AutoHotkey to actually record an AutoHotkey script to actually carry out later on with those parameters specified in there. So in terms of the software servers, that's modified as well in terms of the REST endpoint. So the idea here is if you go to a particular REST endpoint as before here, you get a list of the parameters that are supported by that operation. And there's a form there too that if you access that lets you actually manipulate those parameters and go to the endpoint that specifies those parameters to actually carry out that operation with those parameters set. So in terms of the REST endpoint, it looks something like this, where the parameters are specified and key value pairs kind of here at the end as a URL parameters that get executed on that software server. So that's just the software server aspect of this that wraps the software, provides an API to actually do conversions for Polyglot 2. So this was all wrapped into one monolithic thing in Polyglot 1, and this kind of got pulled out into software servers and the CSR here in Polyglot 2. And so I think here's a good place to take a break, and then we'll talk about conversions again. All right. So basically what we went over is the first two things that got kind of pulled out of the original Polyglot, which was the software servers to put an API on software, compiled code, and the conversion software registry, which was like a database of software indexed according to inputs and output formats. So Polyglot 2 became a bit lighter weight as a kind of, I don't know, I guess middleware, which kind of connected software servers together in order to specifically carry out conversions. So what Polyglot is now is just basically this little service which basically listens for software servers on the network. So when software servers come online, they can broadcast their existence or announce themselves to a particular Polyglot instance. And when a Polyglot hears one of them, it'll basically index it, query it for all the applications that particular software server supports, and then for each application what inputs and outputs they support, and basically build this input-output graph within it. And so basically it can do this dynamically as software servers come online and as software servers go offline. So as software servers, for example, crash and die or machines get shut off, it would remove them from the I/O graph, and as new ones come on, add them to the I/O graph. And so the idea here is, again, like a cloud-based service, it's elastic. So as you have more load, you can bring up more software servers, and if you have lower load, you can turn them off and take them offline. So basically, what Polyglot did is it basically, like in the CSR, it basically searched that input-output graph for conversion paths given a file with a particular input format and a desired output format. So what it basically does is it's responsible for carrying out in this distributed manner these chained conversions. So software servers are all about API. They're all about making a programmable interface to compiled code. Polyglot's all about conversions. It's all about using these software servers, which now have software servers which provide this API to software to actually run open save operations and carry out chained conversions on a variety of platforms. So in this little video here, I'm basically showing a tool on the web that's monitoring a Polyglot instance. And basically what it's doing is showing you the software servers that Polyglot is aware of. So I'm now on another VM turning on a number of Polyglot software servers, and it's showing them pop up as they pop up. I don't know, I thought I did too. Yeah, I did too. So it shows you the names and ports of those servers. Hard to read, I know. And their status. In this case, they're both idle. What software is currently running if they were not idle, what operation that software is doing, and what file it's running on. And it also shows you a list of the clients that are currently connected to this this Polyglot instance. In this case, this monitor tool is connected to this Polyglot instance. I think it's something in another thread, so that's why it shows up twice. So initially, Polyglot supported mainly a web interface. Basically allowed you to drag and drop files to this area in the middle here. So in this case, what am I dragging? VRML file, where then you could specify a file format as the output in this case. And so what it's basically doing is calling that Polyglot server on the back end to actually carry out those conversions on whatever software servers that Polyglot server is aware of. And so when it's done, when it's done with the conversions, it presents them down here. Here's the file itself, and here's a zip file containing all of them if there were more than one. You can also see the details in terms of what actually happened. If something goes wrong, you can see where it went wrong on that particular conversion. And in certain file types, you can actually preview them here. So in this case, we were focusing on 3D files in the beginning, so we had this little 3D previewer. So you can click on the results and potentially, if it was supported by the previewer, in this case OBJ is, see that and manipulate it within the web browser. So back on the monitor tool, you can actually see these conversions being carried out. So in this case here, you should see pop up pretty quickly. Blender is being called convert, now pair of views being called open, pair of views being called save, and then it's done. And that's how I was carrying out that conversion on this particular software server instance. So that's the conversion aspect that Polyglot provided through this web interface. It also provided this, what we called, again, in quotes, universal viewer as a way of previewing data using Polyglot. What the idea here is that you upload some data to Polyglot, it'll convert it to whatever format for that type the browser supports. So like 3D data, we would always convert any 3D data to OBJ files because that's what our previewer supported. And that was a way of kind of previewing any type of 3D data in a way. If there was a path within Polyglot that can carry out that conversion, it'll do it. And so you don't specify the output format, it's hard-coded in here. And then you could preview it down here. So as the things get done, the 3D previewer is being shown down here. And you can rotate around and look at those things. But you can do this with images, with documents, whatever else. And in a way, it provides an easy way of previewing data. So it also had the input-output graph here. So if you clicked on the conversion graph button at the top here, the web interface, it shows you the input-output graph. Like in CSR, you can click on applications and see what conversions can be carried out. In terms of Polyglot, this is more used for not for finding applications, but for kind of getting a feel of what conversions I can actually do on this Polyglot instance. So you could ideally potentially select them all and to see what this instance of Polyglot can actually do given the software service it has available to it. So the web interface was, again, only one interface to Polyglot. The main thing, again, is to be able to program against these things. So there's a thing called a Polyglot client. This is, again, the main interface for the API for Polyglot, which is a Java API that doesn't currently have a REST API. We'll be adding one for Polyglot. But it also has a main to it, so you can call it from the command line, this time entirely as a command line task. So you call a Polyglot client with some file, specify the output format, and then output directory, and it'll actually carry out the conversion on Polyglot, again, running it on whatever software servers are out there to carry out the conversion. There's another little tool called a Polyglot panel, which is basically a JPanel, which looks like a file manager when you run it, and basically makes it look like a little file manager on Windows or whatever else. Shows you the files, you can navigate directories in there. But the idea here is you can click on a file of some type, and it presents you this menu, which it mines from that Polyglot instance, which it mines from the IO graph, all the potential converted output formats it can get to from that file, from its native format. And you can actually click on it, and it'll actually carry it out and dump the file into that local directory. So it's kind of a way of switching file formats in your file system. If you go to the IO graph viewer tool on a Polyglot instance, there's a JPanel version of that as well. If you connect to one and it's distributed, it'll show you a color-coded graph where the edges are color-coded according to which server it's on. So in this case, there's two software servers. One is green and one's red. And the idea here is just showing you that Polyglot doesn't care that they're distributed. It's basically looking for shortest conversion paths across the software and across machines as well. And it'll actually vary the machine depending on its load. So it'll hit the machine and ask it how busy you are. And if it's busy, it'll try a different software server. And in that way, it'll spit out a conversion path, including the host name of the machine to actually run that application on as well. And in this way, if need be, it'll take a file off one machine and transfer it on to another machine. There's a little cost there, but the idea is if that machine is busy, it's better to do that than wait, potentially. So again, just showing the idea that it's distributed, and initially we just did some lightweight tests that show that it is scalable, so that if you do add more machines to it, in this case we called them daemons back then, but different servers, as you add more software servers, at the time you would expect to take as to do a bunch of conversions does drop down. This was for a data set of multiple files, not just one. And so it does is horizontally scalable in that sense. You add more machines, it becomes a bit faster. So again, the main way of talking to Polyglot though is supposed to be through this Java API. So again, the Polyglot client is that instance of that. And let me just look at something really quick. Okay, so the Polyglot client, basically there's a thing, if you look in the code of Polyglot, there's a thing called Polyglot, a Polyglot class, but it's an abstract class. It's not fully implemented. And the idea is there's multiple ways to actually implement what Polyglot is, and Polyglot's all about conversions. So there's multiple. It's all about. It has methods with it in terms of carrying out conversions. It has a convert method, for example, and how you implement it depends on. It can vary. So there's two main classes that implement that right now. One's called the Polyglot Steward. Does probably the bulk of the work in terms of listening for software servers, building an input-output graph, searching for conversion paths. And the idea here is, since it's an instance of Polyglot, you can, if you're running it on a local machine, you can just interface with that directly. And the difference, the other implementation of the Polyglot abstract class is called the Polyglot client, and the difference there is that it's talking to a remote Polyglot steward or Polyglot server who has a Polyglot steward underneath it. So the difference being is it locally run or remotely run. So Polyglot client is actually pretty lightweight. Because it's just talking to a remote Polyglot server, which has the Polyglot steward there, which is doing all the work for it. So in this case here, I'm instantiating a Polyglot client, and I'm telling it to connect to a remote Polyglot server in this case, at this particular, on the local machine nonetheless, but on this particular port. And I can query it for what formats it's capable of supporting for a given file type. So for example, get all the outputs that can be converted to from a VRML file. So basically, I get back a list of that, and I can print them out and look at those. And then I can carry out conversions. So I could just, using the simple convert method here, specify the file on the local file system, the output directory, the output format, and then it'll call that here, execute it, get back the result file, dump it here, and then it'll go on to the next thing and potentially close the server and move on. So basically, that's it. That's Polyglot now that the software servers have been pulled out of it, and the database has been storing all the scripts have been pulled out of it. And so the last element I'll touch on, which is what Luigi already talked about, is verses. So initially this was used so remember we built first this universal conversion engine for the purpose of converting from every possible file format to every other possible file format for the purpose of measuring information loss. And the way we did this is at the time for 3D data, we had this little thing called 3D utilities, which had some methods in it to compare 3D content as meshes. And we load a file before a conversion, after conversion, and see what changed. And later this got pushed into a verses, which is all about, became much bigger than that, just that what 3D utilities was, a framework for content-based comparison in general. And so a number of our things have actually gone into verses now, and building it as a thing of its own. So as Luigi already mentioned, I'll just include it here for completeness. Is again a distributed framework and a service for content-based comparisons. It has a REST interface for calling these things, and it breaks basically content-based comparisons into repurposable and reusable components, which is, I think, an important thing. So again, the adapters, which parse file contents and return to you data structures representing the contents of those files. Extractors, which extract semantically meaningful representation aspects of that content. Descriptors, which describe those semantically relevant features numerically, measures, which then to compare to those descriptors to return a value, a scalar value, indicating how similar or dissimilar those two things are, and indexers, which structure those things so that you can structure descriptors so that you can do fast queries on them. And I'm thinking as part of this project Brown Dog, we'll also add to it something called, I think it will be like segmenters, which will break up content into smaller pieces that can be indexed individually as well. So again, there's a number of adapters already implemented, a number of extractors for a number of data types, descriptors for 3D image, so forth, and a number of measures for those things. And again, our census work kind of fell into this as well. So the idea here is it's all about content-based comparisons, and it's suited for content-based retrieval. So you have, like in the case of our census work, basically a bunch of images with handwritten content in them. handwritten recognition isn't up to par to translate what's in here into actual text, the pixels here. And so how do you search this stuff when you have 3.6 million of these things? You don't want to search through the 3.6 million JPEG images. You want to do something else. So we did a content-based retrieval using this technique called word spotting, which is now part of Verses. It's basically just another way of comparing content in images based on handwriting. And so the idea here is you would type in some text. It would create a query image with some handwritten text on the back end using some font that looks like handwriting, and you get back some similar looking snippets from the database of these cut out images that look similar to that, and you would find things based on that. So that's kind of the idea of content-based comparison for content-based retrieval, and what I think is really cool about Verses. So a number of our things have gone into Verses that is kind of subsumed now. The first was, of course, the 3D utilities used in Polyglot initially for 3D comparisons for our initial experiments with 3D information loss. Doc2Learn, which was a way of doing this for finding similar document files, PDFs and Word documents in an archive to find duplicates and what's it called, provenance in terms of derived files and edited files over time. The comparisons and the indices that went into our census work have gone into Verses. The comparisons, I believe, in the LSVA work have gone into Verses as well. And we've also included a number of functionality from stuff like OpenCV and ImageJ in there as well in terms of image comparisons. And I just leave off saying that what Luigi was iterating was that Verses is what it's all about. It's a framework and a service, a distributed web service for content-based comparisons, the main thing being making consistent, reusable, repurposable components that can be mixed and matched outside of what they were initially intended for, I would say, potentially. So that's basically the four parts that came out of the initial Polyglot. So the software servers, the CSR, Polyglot 2, and what became Verses, all for the sake of, again, going back to doing this idea of identifying an optimal file format for initially 3D data. And so the idea is once we have that, so through Polyglot and through the software servers, we have this, in quotes, universal conversion engine, in the sense that I could just keep adding software to it and incorporate more conversion functionality that the IO graph would see and the Polyglot would see and take into account. And so in this way, I've built this conversion system to convert from any format A to potentially any format B. And then assuming I have a way of loading format A and format B, I can then compare the content before and after, and that's where Verses comes in to look at the file before and after and see what actually changed. So basically what this means in terms of measuring information loss, what this means is in that input-output graph, what we're talking about is basically assigning weights to these edges in the graph. So as we go from step to igest using this is an application, each edge, give it a weight, indicating how much information was preserved or lost during that conversion. So graphically what this might look, and this is an actual conversion using this set of applications here, going from step to X3D, it's using two tools in an intermediate format of VRML, using this NIST tool to go from X3D to VRML, and then Adobe 3D Reviewer to go from VRML to step. And so you can see here in the first conversion, using two sample models to test with, the first conversion to VRML, we have loaders for all these things, so we can look at the contents of the files through each step. And see that the first one was good. It looks pretty much the same as it did going into it. The second one, not so much. A bunch of stuff got lost, the faces in particular. I can still see the shape of it, so it's not total loss, but it's not so good. So the idea here is this first one's pretty good, give it a weight of maybe something like 1, and the second one, not so good, give it a weight of something lower, like 0.1. So there's a problem with that, obviously, in that if we were able to load every possible file format, we wouldn't have to do this software reuse thing to build this converter. We could just build the converter ourselves. So obviously that's a no-go. So what we did instead was we made a database of a certain type of file formats that we could support. So 1 or 2 file formats that we could load. And then what we did was using Polyglot, converted to every other possible file format we could reach from there, and then back to that original file format again. So in that way, we could load the original file format. So we loaded it before the conversions, after the conversions, compared it, saw what was lost, and kind of distributed the information loss across the entire conversion path. And we would do this for a bunch of different types of data or a bunch of different types of conversions. And the idea was kind of hand-wavy here, but hopefully it would converge to some sort of indicator of information loss. This actually is somewhat analogous to what's called, I think, Q-learning in artificial intelligence. It's a type of reinforcement learning. And that does converge if you can prove that it's a Markov process, which we haven't done here, but potentially, if it is a Markov process, it would converge. So, so basically the idea here is you have some initial file format, you convert it to some every other possible file format. So in this case, we're going through every path to X3D and then back to the original file format. And you can see here something happened along the way, so some information was lost. And you would assign that weight to the entire path. There would be multiple paths that go through every subpath here, though. So the idea is here some would be better, some would be lost, worse, and hopefully the problem areas would get the higher information loss weights than, and the other ones would get upweighted by other paths that do okay. So we built this little tool called the IOGraph weights tool, which kind of basically lets you select a data set, select a polyglot instance, and basically it would just go through the IOGraph and carry out every possible conversion it could, from the source format to every target format it could reach, and then back to the source format again, and through that build these weighted edges. So then what you could potentially do is, instead of searching for a shortest path in conversions, search for a shortest weighted path in the conversions to find one that ideally would have the least amount of information loss. So here I'm selecting the source's step and the target is OBJ, and it's showing me the shortest weighted path in this case, where the weights are being indicated here using some particular measure in this case. So that's the whole setup then. So basically we have this layered architecture where we have our software, our API provided by the software servers, our conversion through Polyglot, and our comparisons with verses. And we get this thing here where underneath at the very, it's kind of flipped around now, but the applications are here. The script installer queries the CSR to get the wrapper scripts for the software servers. The software servers talk to software clients, which talks to the Polyglot steward, which makes a software server, which has various clients of its own, like the IOGraph weights tool, which talks to verses to set weights for this Polyglot web interface. So going back to the whole point of why we did this in the first place, the information loss for 3D data. Basically, what we did was we had this data set. We had to pick a representation in which we were going to support the data in. We picked meshes because they're easy to implement, as opposed to BREP or CSG or something else. So all data was loaded as meshes as the data structure in memory. And then we had to build loaders for a certain set of file formats, and we did this for a number of them, OBJ, STEP, and a few others. And then we picked a number of similarity metrics that we would use, measures that we would use to compare the contents before and after. And the idea here is another aspect of what I think is important about verses is that there's more than one way to compare stuff of even the same type, 3D data, for example. And they're different ways. They're good at certain things and really bad at other things in terms of aspects of the data that it kind of clings on to. So the idea is that kind of application dependent. So for example, for in manufacturing in a CAD model, you would be most interested in the geometry being preserved. Whereas in a graphic designer, maybe they don't care so much about the geometry as long as it looks good. So there's potentially two very different ways of measuring things in terms of that. You can let one go and not the other. So we used 4 different measures, one being very simple, just some statistical stuff in terms of the mean and standard deviation of the vertices inside of a mesh. So it completely ignored the faces. But it's kind of like a baseline. It's fast to compute. It's sensitive to the size and orientation of the model, and it was just kind of an easy way to do some kind of comparison. The next one was a surface area. So this obviously includes the faces of the model. This was actually used in a paper out of a tech report out of Volkswagen to do some kind of comparison on, I think, some aspect of information loss. So basically, it's also simple, fast to compute, sensitive to size, somewhat sensitive to shape, and will detect loss of faces where the statistics wouldn't. And then we get into more complex ones like the light fields. This is based out of a paper from, I forget what conference, in 2003 though. And basically what it does is it compares silhouettes. So what it clings on to is the shape in terms of the convex hull of an object. So what it does is it takes a 3D model and it aligns it according to its principal components. So it aligns it with the XYZ axis according to those principal components, the first 3 principal components. And then it does basically, it looks at the silhouette of those. So basically it generates these black and white image maps of those things. So basically these 3 images represent that model from these canonical views, the front, the top, and the side. And so this is how it compares 2 models. It'll take these image maps between 2 objects and compare them as an image using cross correlation or something else, and see how similar 2 models are based on that. So like in the case of this object here, and this is what its light fields looks like. And so you can then do something like in this, this was part of the 3D utilities also, this model browser. We can click on multiple 3D models here, and they would all appear here and show you how similar they are to one another. Or these are the weights indicating how similar they are in terms of the light fields measure in this case. As you can see, they're all different things. They all have high weights. But light fields are sensitive to shape, but because of the fact that it's aligning the principal components of the model to the axes, it's not sensitive to orientation changes. So in this example here, where I had done this conversion from OBJ to VRML, and for some reason it got rotated, so I loaded it back in here and did a comparison between the two, but it's 0 because light fields doesn't care about that. It doesn't care about the orientation changes. So that's kind of like one of the how the different measures are different. So light fields doesn't care about orientation changes. Also, it doesn't care about scale. So basically, this is what it's good at. The last thing we use as comparison is something called spin images. Basically, for every vertex, what it does is it builds a two-dimensional histogram of every other vertex in relation to that vertex and kind of maps them down to this 2D histogram, which is basically a little image down here, and basically compares those. So usually what's done is you build a dictionary of those things for a model, but we just average them all together and make one spin image. So you would build one of these for every vertex, and then you average them all together to get one kind of spin image for the whole thing. And you do these for separate models, and then you get different images for these. And then you would compare these. Well, these are actually histograms. These are large ones for visualization purposes, but usually small ones, between each other to see how similar the models are. And so in this case here, you can see this with the 3 models from before. What's kind of interesting about spin images, though, is that it kind of captures a higher level aspect of what similarity is in a way. So like these curly things here have a lower distance than they do to this airplane here. And that's kind of a nice aspect of that in terms of comparisons. It's also not sensitive to orientation changes and scale changes. So when things got flipped, it's still 0 in that case. And it's also capable of doing subparts. So that's actually the reason I think the initial paper was written for. Back in the days, well, I guess still even today, with laser scanning, you'd have certain perspectives. The laser scanner can obviously only see one side of an object at once. So you do multiple laser scans all around the object, and then you have to stitch them together. And so what spin images would be used for is like finding similar shapes on the surface of the surfaces and line them up. So you can use that here in this case to find subparts of a model. And so basically here, this wing of this thing which I chopped off and made a separate object is a smaller distance of the plane than these other 2 objects here. So different things. They capture just different elements. So spin images, though, are pretty expensive to compute because it's computing that histogram for every vertex, and there's a lot of vertices that can take a while. So basically, that's everything we needed in terms of our experiment. And so we basically had our universal converter. We had our way of comparing content before and after, and our methodology of doing it through this ABA kind of conversions back to the original. Load it before and after and see what changed. And then through that, we can somehow define what our best file format was. Again, taking into account the fact on that data set, using those applications, what that best file format was in terms of which one resulted in the least amount of information loss given the initial set of formats to every other possible format. So in that experiment, which we published in a paper, I think in 2009, basically, first we looked at which conversion, just one single step, did the best, and it was through Adobe 3D Reviewer from PDF to step. This was using, I forget, light fields as the measure. I think higher is better. And using spin images, it was, again, Adobe 3D Reviewer through OBJ, through PDF. Again, this is dependent on the software being considered and on the data set. The idea is an archive would run this again with their software on samples from their data, so they would be relevant to their data set, to them. And so which is the best format? So it depends on which measure you use. So if you use the light fields measure, the best format is the step format in this case on this data set. On these applications, I can't emphasize that enough. Basically with this particular measure of information loss, if you change that though, so that was with the light fields, which emphasize shape, the silhouettes of objects. If you change that to spin images, it came out to be a different format, STL, which is one that's is a faceted representation. It represents points and it represents meshes. That's perhaps a bit biased because remember we're storing as our data structure meshes, and so any object format that didn't do that had to get what's called tessellated, sampled into a mesh. So like files that were in our data set had step files in them, so they had to get tessellated and converted into meshes. So they were kind of handicapped in that sense. But it's the nature of the beast, and it's something you just have to keep in mind. Different measures, different things. But in this way, you're able to fix this according to your particular needs and establish what is the best file format for your particular needs. So in conclusion, so basically why all this was built was, again, for that kind of experimental setup. And the idea here is with the CSR, we ended up cataloging 2007 applications. They're not all scripted by any means, but we have these in our database through 1,600 different file formats, which is a big blobby mess. But the idea was you could then ask questions of this with this Polyglot and software service in verses. Questions like which image format is best for information preservation, which image format is best in terms of file size. So maybe I don't care about information preservation as much as I care about having a small archive. I just want to save as much space as possible. Which file format can I revert to that results in the smallest file sizes in the end? Which image software is best is best by terms of preservation purposes. So first of all, let me emphasize again, these says down here, this is all made up stuff. I'm just trying to get an idea of what kind of questions you can ask. And you can do the same thing for 3D formats in terms of preservation, file size, and so on, video formats, and so forth. And the whole reason we're interested in that in here is in Brown Dog is for this thing that we're going to build called the Data Access Proxy, which is a service to deal with file format conversions, so that hopefully it's file formats are issues with file formats are a thing of the past, and services in the future can be agnostic to whatever format any data is stored in. So this is where we get into the hands-on part. So if you have your VMs started up, if you don't, start them up. So let me start up mine. So again, the idea here was setting up a virtual machine for the hands-on part was that this is a cloud-based service, and VMs are a big part of what the cloud is. Uh-oh. Okay. Part of that, so I wanted to make sure everybody, especially the new people, were comfortable setting one up. The other aspect of this is this was primarily developed on Windows. AutoHotkey, for example, is a Windows program. I think there's a port for Linux, but I don't know if it's supported any longer or how well it even ran in the first place. I never tested it. So most people here are running Macs also, so that's another reason for having that. So if you go to that, let's go to, did anybody have any issues? I know there was some hiccups in terms of Maven. I don't know if everybody got it fixed, though. All right. So, where might we go? There we go. So the first thing I would like to just let people actually interact with the CSR, I would say. So obviously, Rob and Ludi, you don't care about this, but but for the new people, why not to give it a shot? So if you go to our website, isda.ncsa.illinois.edu, you can access it from there. So if you go there and you click on Services, it's the first thing up the top here, the Conversion Software Registry. So if you go there, you can actually query it for software to convert from one thing to another. So you can type in stuff like JPEG, easy stuff like JPEG to TIFF, and you'll get back a list of all the software in the database that it knows of that's able to actually carry that out. Did you find it, Edgar? You can so you can tell it to include intermediary formats as well. So hop across one format using two applications to get there. So if you do that up here, the number of intermediaries, you can select between 0 and 4. It'll take that into consideration with its query and return to you a list of chains of applications that are able to carry that out. So the purple stuff are the formats, the intermediary formats that it's considering. So you could potentially do several hops. I think it takes a little bit longer when you do more hops, and I don't know. I should be doing this with multiple people hitting it at once, but we'll see. Two can take a while. Oh, I probably should have told it to only do a few. Oh well. But something you can do is you can see that the potential, and for the potential actually in the data access proxy, if there's enough support in the back end in terms of software services, you could do potentially kind of weird things. So I think one of those I was trying before was a JPEG to a doc. And the idea here is it would find conversion chains that would potentially carry that out. So an image file format to a document file format. Oh yeah, Michael, we're bringing it down. Is anybody else getting through? Yeah, probably because I did that chained one and still going on it. There's only one server and it's running MySQL. It's not meant for production by any means. Well, anywho, what's kind of nice though is if I didn't stall it out was you could do weird searches like from different file types to different file types, like 3D to audio, which would be weird. Or in this case, I wanted to show you here was an image to a document, and it'll always search through that, chaining together stuff that actually could potentially carry it out. So a lot of times it's going to be weird stuff that's not really intended to be what it does, but sometimes it'll work. Like in the case of this one, it would find OCR software. So like Abby Find Search is in here, so it'll find a chain that includes Abby and is able to carry out an image conversion into a text document and other stuff. So potentially if there's like text-to-speech engines in here as well, a TTS, it could potentially convert text documents into audio files potentially and stuff like that. So I think that's kind of neat and something that might be a little bit unexpected in terms of what's potentially doable in terms of like the data access proxy that we're building here. So I'm going to give up on that. But so everybody, why don't you open up Eclipse, and I'll just go through the code a little bit and run things here and there just to give everybody a little bit of a feel of how things are set up. Where was that? So if you go into the source code folder under, where is it at? Under source, main, documentation, there's a little file called here, a little README called Windows Quick Install. So if you open that up, it gives you the minimal amount of steps that you have to do in order to set this up, set up a software server in Polyglot. You can ignore the first part, which is opening up the ports, because you're not going to be connecting to any remote servers. It's all local through localhost. But and I think you did most of this already, so you obviously installed Windows and installed Java and AutoHotkey and downloaded the source. So one thing that you could start trying is open up a command prompt and run the script debugger to actually install the ImageMagick script. So if you look here under Polyglot scripts, we include with it a bunch of scripts that we've created over the years. So there's a bunch of them. But they're configured for default conditions of whatever development environment they were on, so they should still be set up for the local machine. So if you open up a command prompt and you go to your source folder, so I just did mine on the desktop, so cd Polyglot. And if you do debugger -config, and then you have to specify the path to the script. So the scripts are where I showed you here under scripts AHK. So I want to just do ImageMagick because that's just an easy, lightweight one. So there's a bunch of monitor scripts here. So there's a monitor script for that and a kill script, but you can get away without them. Some of the times it's just when things go wrong that you need them. So we'll just do the convert script. That's the essential one. So if you do, you have to specify the full path. So under scripts AHK ImageMagick convert AHK, and so if you run this, it'll basically do that search. It finds the executable here, and basically it looks. So in this case, it wasn't correct on the local file system, and so it looks for alternatives in program files. It found one, and that is ImageMagick. So I'm okay with that. So I press 1 as the option that I want to pick, and it basically saves it in a configured form into a different folder, which we have to check next. So it's actually dumping them not into the original folder, but it doesn't want to touch those. It creates another folder called AHK configured, and this is where it's stuck it. I have a few other things here, but you should just have that one thing. And so once that's done, you can actually start up a software server. So what you want to make sure, though, is that it's configured correctly to point to that correct folder. So there's a bunch of configuration files if you go back to the root directory all the way to the top. And the one to look at is the softwareserver.conf file. So I have BI, but you might be using Notepad to see this with. And so you can see a bunch of different configuration options for the software server when you start it up. So one is like the first, it's important to set correctly, but this is in the repository, is a temporary folder where it sticks intermediary files for the requests that it gets. So the files that are getting sent to it, it gets dumped into this folder called temp software server. And there's other stuff here, like which port to use, the operation time, like how long to wait in milliseconds, 30 seconds, before it'll actually try killing stuff and restarting. This is in the root folder called softwareserver.conf. Did you find it? And a bunch of other stuff in here. So enable monitor, so whether it'll try to use the monitor scripts or not. So you could potentially just risk it and run without them, or turn them on. Whether it tries to auto kill scripts or not, stuff like that. But the important one is to check is this one, the folder where the scripts are. So in this case, the AHK scripts equals scripts.ahk configured. I don't know if that's in the repository that way or not, but make sure that's there and uncommented. You can specify multiple paths, so you can have a whole bunch of different script folders, some of them with different kinds of scripts, like Python scripts and so forth, separately, but we don't, so we just have those commented out. And then you could potentially, in the software server, specify a Polyglot steward to connect to. So when the software server starts up, it'll automatically try to attach itself to a Polyglot steward, or you could just tell it to broadcast its existence over UDP. So that's what we have set up here, so that's fine for our local install here. So basically a software server, a Polyglot steward, a Polyglot server that starts up will just listen for these, and anyone that it finds will just add it to itself. So once you've done that, you can, let's just do this through Eclipse. I got too many things open here. So if you go here, you can just run source main Java. Oh, sorry, let me show you one more config file. So usually you run the software server through the REST interface. So there's a separate config file for that, and you can just open that up to see it. Basically here again specifies a port for that through HTTP, and this is something we'll ignore for now. It's something called a distributed software server to connect to in addition to a Polyglot server. And here's also where you can potentially set usernames and passwords, so you can specify accounts. And if you name an account admin, it has special privileges. It can actually take screenshots of the machine and reboot the machine, so you want to be a little more careful with that one. This obviously needs to be strengthened a little bit over, and that'll be something that we intend to do as part of this project. So now what you would do is then go to Eclipse and start up the software server RESTlet. So you could just click on that and then click Run, and it'll basically, using the configuration file, look at that directory with the scripts in it and start up. Usually pretty quick. I don't know what's up with my system. Oh, I have multiple things running in here, by the way, so it sees multiple things. But it basically shows you the available software based on the scripts it knows of. And so you should just see ImageMagick. It tells you that it's broadcasting itself over UDP, and it tells you that it's running. So what you can do next is then, is everybody okay? Did anybody have a problem with the script debugger? Oh, because yeah, that was the first thing you had to configure was the script debugger. So there's a configuration file for that, and I caught this just at the last minute today, and I didn't check it in. But if you go to scriptdebugger.conf and get in the root directory, there's a data path at the very top here, and this is basically wait, what? No, that wasn't it. Where it looks for the scripts? No, that doesn't matter. But there was something somewhere where I did fix it at the last minute. No, that has to do when it's doing the testing operations, and it's not. We're not doing that. No.
But you said that you first configuration use script debugger, right?
Yep. Yeah, but it's fine because it's not using this. It's not testing anything. It's not even. It's not. You would set this if you were testing data using test data, but we're not. And here's actually where you set the search path to, so you can limit where it searches to save time. So it's just searching in program files here. Right here. So I typed in this command script. So at first I went to that folder and then I typed script debugger. You don't need to edit it. You can just type this command. In the command prompt, you go to the directory wherever you unzipped it to. You don't have to edit it though.
No, I mean I just checked this out straight from the Git,
Uh-huh.
and it doesn't have a executable for. There's a little tab or whatever for script debugger. There's just the conf file.
Why do I have a bat file? Wait a minute, that's a good point. Yeah, then you have to run it from Eclipse and pass it the arguments to there. Yeah, that's a good question. What am I running? 'Cause I don't think I have a bat file either. I used to, and then I refactored the thing and moved everything around. It's like magic. I don't know why it's running.
Have the script debugger on your pad somewhere.
There's no which command in Windows, is there?
There's a batch file
Anywho.
for assembly Windows.
How do you run this from? Hey, Rob, what's the way you pass arguments in Eclipse? You run configurations. Arguments, program arguments, dash config, and then the path. I'm assuming it's running from the same directory, HK.
It's running.
Wait, did I click on the right thing? Should begin that one. I don't know why it picks the last thing I ran. For some reason, I had to run it once without any arguments, have it fail, and then I just went to run configurations and edited it. Then it showed up here and added the arguments. All right, so most people are there now. So after you got the script debugger thing figured out, which all you have to do is run the software server RESTlet, making sure that in the conf file that it has that valid folder AHK config set there. So you can just run this without any parameters from Eclipse. And then you should see something like this. Can you see that? I don't know if it's committed in there or not. Is it AHK config? So once you start the software server RESTlet, you can access it from a browser now. So you can open up a browser and go to localhost port 8182. And you should see just one thing with no icons because we didn't use the script installer. But you should see ImageMagick, and you can click on it. Oh, let me go back. So all you have to type in is this. So first you run the software server RESTlet. Yeah, you can't run it twice. That'll get you a bunch of errors. So there's a test image here. So first of all, by default, you get the version of the form that uses the get method in HTTP. So basically, you have to paste the URL here. You can change this to the one where you can use a local file by changing this to post, changing the get up here to post. And then you basically get this one where you can view a browse and select a file. Yeah. This one? Oh, this is the one you just have to go to. Yeah. And then click on ImageMagick and you get the other one. Change get to post. Just so you can send a file there. So ImageMagick is just a quick one to test. It's the one that's used in the integration test in the system to make sure everything's talking to each other properly. But obviously, that's not testing power of the software service, but it's just a command line thing. So two simple ones we can do in Windows is Word and Paint, because that's always installed. So those is, I'm assuming everybody's tried the image stuff. So what you could, so for to install Word and WordPad, sorry, and Paint, go to the HK folder, and these scripts don't need to be configured because they use the system path. So just find the one that says WordPad _convert. There's only one at the bottom here, and find the one also that says Paint 6. Paint 6 _convert, and copy those two files to the HK config folders. So if you've done the step of copying those other two scripts to the HK config folder, you can just refresh your kill the software server RESTlet and then start it again. Just press the stop button and Eclipse. And start it again. Oh, so we so we're running out of time, so maybe we'll just, I don't know, stop now? Yeah. Well, anyway, let me show you this. So if you, to use the rest of it, you could go to our webpage and you go under Software, and if you scroll to the bottom, there's Polyglot, and under Documentation, there's Web. So this is the web documentation for Polyglot. So it goes into all the details of how to set it up and install everything. And so the next thing I was going to have everybody try, which I think we'll just skip, is running the Polyglot server and trying out the Polyglot panel. So basically, the difference here is this Polyglot steward in the backend is going to be calling this one software server you have running on your local machine to carry out the conversions. Then you can just right-click on files and convert them straight from that window there. But in theory, all that's required to set that up is just run polyglotserver.bat at this point. But I think we'll just stop from there. I don't think this, yeah, the default configuration is fine. Well, if you want, you could just try starting up the Polyglot server and then so you leave the software server RESTlet running, start up the Polyglot server. It should, in the command and output, you should see it detect the software server. Where is it at? So Polyglot's in the Polyglot package, so you have to open that up. And then there's Polyglot server. Just run it. And you should see, it should show you found software server. This is your local machine. And then it should be good to go. And then the last thing to use it would be to do the Polyglot panel. You would edit the conf file for the Polyglot panel. And just make sure that the default path is set to a valid folder. So I'm pretty sure in the repository it's not. So just change it to data, which is a folder that's in the repository. And once you do that, you should just be able to run Polyglot panel and use it. So running Polyglot panel. And it should open up. And then you can do stuff like convert. Click on something, and it should convert it. Like that. All right, thanks, guys.